Hello students, let us discuss with unit number 6, which is our active filter. First of all, we will discuss with the objectives and outcomes of this unit. Objectives are to understand the basic concepts of active filters using op-amp, to analyze different types of filters, to design first order and second order low pass filter, high pass filter, band pass filter and band stop filters for different cutoff frequencies. Outcomes of this unit will be, when we will finish this unit, you will be able to understand how to design first order and second order low pass filter, high pass filter, band pass filter and band stop filters. You will be able to plot the frequency response of above circuits. You will be able to understand the concept of frequency scaling and frequency transformation. Now let us come to the introduction of the unit. Now, what are filters? Filters are those electronic circuits which are able to either pass or block a required range of frequencies. Depending on which types of frequencies are getting passed or getting blocked, they are classified as low pass filter, high pass filter, band pass filter and band stop filter. Now this property is also called as the frequency selectivity property. This is also called as frequency selectivity property. Now the filters, they are also classified as active filter and passive filters. Now active filters and passive filters, they are having a basic difference, that the passive filters, they are consisting only RC, RL or RLC components, whereas passive filters, they are consisting of one or more than one operational amplifier to design in the design, along with this combination of R and C. What are the advantages of this active filter over passive filter? uh, these passive filters, actually there is no any active component, so they provide, along with the passing and stopping of required frequencies, they also gives some kind of attenuation, because we know that R and C components, they actually dissipate some power. When I'm talking about attenuation, it is like dissipating some power. Okay, so we will, these passive filters, they will not provide any kind of gain, whereas if I'm talking about active filters, there is an introduction of one or more than one operational amplifier which is capable to provide a required gain. Means these active filters, along with performance of passing and stopping of the required band of frequencies, they will also provide us the gain. At the same time, we know the properties of op-amp, that op-amp is having high input impedance and low output impedance. Now this property will be there in the active filter, which will avoid the loading effect. At the same time, these active filters, they are cost effective due to the use of op-amps. Now where these active filters will be used, they will be mainly used in any kind of communication system, because see, if I'll talk about a simple FM radio example, it is consisting of different frequencies, and that different these different frequencies, they can be selected with such type of active filters. They are used in many medical equipments, entertainment equipment and so on. So this, we just talk about the types of filters. Now let us start with the frequency responses provided by filters. This gives us the frequency response of low pass filter. See, basically first concentrate on this circuit. This I am showing first for the better understanding of the circuit. I am providing you with the basic RC component. Now see the position of R and C. Here C is in parallel with the load. C is in parallel with the load, and this is your basic passive low pass filter. This is showing you the ideal response. Ideal response means what? See, if this is your cutoff frequency and uh, see, the frequencies which are less than the cutoff frequency, they are getting passed with the gain 1, but frequencies which are greater than this cutoff frequencies, they are getting blocked, means the gain is not available. Okay, if I am talking about the actual response, this is what happens ideally. Suddenly at the cutoff frequencies, the gain becomes 0, but practically this type of response cannot be achieved. So practically, that is actually, we will get some kind of roll off rate. Roll off rate means the rate at which the gain is getting dropped, right?